Sammy Space Owl. It's been the mascot of the Space Physics and Astronomy group at Rice University at least since 1988 and maybe earlier, but I saw a t-shirt that was a 1988 t-shirt that had it on it. And in fact, I've got a pin of him as well on my jacket. So I wanted to talk a little bit about, how I got where I am and also a little bit about the launch that's coming up tonight, which is kind of timely. Okay, so.
Very exciting launch tonight, yeah.
Yeah, well, I didn't mean to do that. I was getting back. So, I like to say I was a child of the space age. I was 7 when Sputnik flew, and I remember my mom taking me outside and looking at it going over and Telstar, and I was 10 when the first humans flew into space. I was 12 when JFK gave his to the moon speech from Rice University, where I am right now. And I mean, little did I know that 9 years later, I would be on this campus and basically spend the rest of my life here with a short divergence to NASA for a while. But my mom earned her medical degree in 1942, one of only 2 women in her class. And so met my dad in medical school, and there was, no question that I could do anything I wanted to do. And I had great expectations that I was going to do something fun. So I dabbled in, medicine, and I thought about being a vet and whatnot. But when I was a Brownie Scout, I went to a father-daughter astronomy class at the Oklahoma City Planetarium. And it was 6 weeks, and I was, dazzled, because even though the planetariums back in the day were pretty primitive by today's standards, it was still my first understanding that the universe was understandable. And I think that was really engaging to me as a child. Here's something that's a mystery, and we know so little about it. And with the space program in its infancy, I could see ahead of me a whole vast ocean of things to learn that had never been learned before. I did my degree at Oklahoma State in low temperature physics, and we were looking for superconductors by putting alloys down into a tank of liquid helium, and that was okay, but kind of boring. And then I spent a summer at Argonne National Lab doing low temperature physics in a lab and getting triple point measurements of liquid helium, and spending all day to get one data point, because we were doing it to 12 significant figures. And I remember at the end of that summer saying, I don't want to do anything to 12 significant figures again. I want to go out and learn the first digit. I want to be the first one to know something. I don't care if it's all that important, but I want to be the first one to know it. And so when I graduated from college, I married my college sweetheart, who immediately went into the Army to avoid being drafted in Vietnam. And so he was doing his basic training the summer after we graduated from college, and I didn't have anything to do. So I got accepted both in the physics department and the space science department. And I said, who's got a summer job? Because I don't have anything to do, and I'm going to be in Houston anyway. So they said, well, we just put an experiment on the moon on Apollo 14, and we need someone to help do the computer programming to analyze the data. And I went, me? And I've basically been counting electrons and protons ever since. And it's been a fun ride. I mean, you'd think I'd get bored with it after a while, but we've managed to really learn a lot about the Earth's upper atmosphere, its environment. The Northern Lights is one of my specialties. And it's been a real thrill to really be on the ground floor and many of these amazing discoveries, some of which were my personal ones, but even the other ones that happened at the same time were still really fascinating and really, really engaging. I was just at a dinner on one of the residential colleges just moments ago, and one of the students asked me, what was the most amazing discovery in your lifetime that you remember? And I said, it was the volcanoes on Io. That was just so completely not expected. And as we approached Jupiter, with our cameras, and we saw this moon that looked kind of like a pizza. And I remember one of the scientists saying, whatever disease Io has, I hope the spacecraft doesn't catch it. But it was the computer programmer who realized that there was a volcano in Io because they were doing navigation by seeing how big and how far all the 4 Galilean satellites were. And Io wouldn't fit to a circle. There was a big bump on it. And that big bump on it was from a volcanic plume. So those are the kind of things that, get my juices stirring to really, every time we've been to a new planet, every time we've used a new kind of instrument, we've learned something new. And as Proust says, the true voyage of discovery is not in seeking new landscapes, but in using new eyes. And I think the spacecraft missions that I've been involved with were new eyes on the cosmos. Well, my prepared presentation was kind of to talk about a little bit about some of the women that have been involved in astronomy and space research. And it certainly goes back to Carolyn Herschel, who discovered several comets, and Maria Mitchell, who discovered also a comet and observed sunspots. Annie Jump Cannon and Henrietta Leavitt both worked for Pickering, and Henrietta Leavitt found the color magnitude diagram, and all of these women are, sort of the shoulders of giants that I've been standing on throughout my career. And the point is, you have to persist. That the graduate school is 10% inspiration and 90% perspiration. And I think none of us who ever got a PhD didn't want to throw it over at least once or twice during the course of your studies. And sometimes life isn't fair. Jocelyn Bell, she was the one who really discovered pulsars, but she was not the one who got the Nobel Prize. Her advisor did. And similar, Katherine Johnson and a lot of the hidden figures, really worked tremendously in the early days of the space program doing the calculations by hand that got us to the moon. And if this is a radio talk, so I gotta give you the Vela pulsar in honor of Jocelyn Bell. And then I'm gonna give you, the that's the crab. And when you think about it, each one of those blips is a spin of a neutron star at the center of the Crab Nebula. That is radio astronomy, and that is some of the most really exciting things. And there's no surprise that there's a tight connection between radio astronomy and ham radio. If you look at, one of our radio science pulsar Nobel Prize winners, he's also the author of the FT8, data compression that we all use in tracking balloons going around the Earth. So the combination of citizen science and real science is never more noticeable as in astronomy. I remember when Levy of Comet Shoemaker-Levy 9 fame came to Rice to talk, and he said you know, some of the most interesting discoveries in astronomy are made by, or at least at that time, were made by amateurs, because amateurs astronomers had actually the time to look at the sky, whereas professional astronomers were writing papers and writing proposals and teaching students and analyzing data, and were in front of a computer all the time. And so you didn't get the chance just to go out and look at the sky like he did. All right, so women into space, of course. The first was Valentina Tereshkova, who went in 1963, and the next woman was not until almost 20 years later, Svetlana Savitskaya. And both of them actually continued in science for quite a long time. The first American woman in space is Sally Ride, and I had the pleasure of knowing Sally. She was an astronaut, about a contemporary of mine, and she would come up to Rice because she was an astronomer by training. She'd come up to Rice for the seminars and colloquiums because she wanted to keep her hand in astronomy, and she also was dating one of the guys at Rice. But we've been really fortunate to have quite a few wonderful, amazing women in space. And some of these have Rice connections, like Catherine Sullivan was an adjunct professor, and Peggy Whitson was a Rice alum as well. And then more recently, Shannon Walker was on the first crewed mission. There have certainly been women who've died in space, and I think the point is, you know, space research and space travel is not a trivial thing, and so the Challenger disaster in '86, the Columbia disaster in 2003 were really shocked the world that, you know, so many people would die all at once. And they just found another giant piece of the Challenger offshore in Florida just last weekend. And we like to think that we have the right stuff. We've got, you know, 14 faculty or students that were involved in the space program. We got 2 new ones now, so I got to redo my map. But the administrator of NASA just previously, Bridenstine, is a Rice alum, and we have another new woman astronaut. And so women have really been on the move in science, and so, you know, we're seeing, this is the women that are associated with the New Horizons missions. This is Fran Bagenal, is a good friend of mine, but you notice a lot of them are younger, and we're just so pleased that we're training women to do science. It's not the anomaly to be a woman in science, but it's actually quite common now. And in fact, the head of the heliophysics division at NASA headquarters is a woman, and her name is Nikki Fox. Just had her birthday last week. And this was at the launch of the Parker Solar Probe that was named after Gene Parker, who was really the first one to try to understand how sunspots occur on the sun. And he passed away. He was there for the launch of the Parker Solar Probe, but passed away last year. This is the mission I'm working on now. It's MMS, and you notice we have a fair fraction of women associated with it. This was one nice thing about space science is you get to, you have colleagues around the world, and you get to go to fun places for meetings. So I got a lot of miles on my United account. But you know, we're upcoming now that it was that all the crews were all you know, NASA, and now we're getting commercial space pilots coming up. and some of them like Sunny and Nicole are just really amazing, amazing women that are going to be the next people that go into space. And Nicole is the first Native American. Oops, I didn't mean to do that. Nicole is the first Native American to go into space, and we're really excited about that as well. One of the really exciting situations is the launch of the commercial space, and the first demo crew from SpaceX were men, but the next full crew, Crew 1, had a 4-person crew, including a Rice alum, Shannon Walker, and we were just, I mean, talk about brave. It takes a lot of nerve to sit on top of a vehicle that's never been used for humans before and realize you have all this firepower underneath you, and you're never sure what's going to happen. So these are the heroes that they really are brave and are trying out the new epoch in space travel. Both the commercial side is new, and now the Space Force, the new military, is new. And in fact, the Space Force just landed a space plane that's been in orbit for 3 years, and nobody really knows what it was doing, but it was part of the Space Force. So Shannon was aboard, and she very nicely took one of my baby horses up into space with her. So this is Trigger MMS. He's my mascot, and so Shannon took him into space with her and brought her back home. I actually have 2 Triggers that are twins. This one's now been retired, but I have another one that's been on 2 radio balloon flights at 200,000 feet. And so that's his twin brother. On the balloon flights, we took all his stuffing out to make him light, but I said, do you need me to take out the stuffing on him for space? She said, nah, I got lots of weight. So I said, okay. Suni is going to be one of the first Boeing operational missions. And so there was sort of a competition to see whether SpaceX or Boeing would be able to launch the first commercial space, and SpaceX beat them. I mean, Boeing still hasn't gone up yet. So, but a little competition's good, and I think that that makes things work better. All right, so outside Earth, what's next? Humans have not left near Earth orbit since Apollo 17. I mean, that's 1972. That's a long time ago. That's 50 years ago was when we left the moon and have not been back. And in fact, we've done surveys of teachers and asked them, does the shuttle go to the moon? A good fraction of teachers think the space shuttle went to the moon. But in fact, it was Gene Cernan who was the last man on the moon, and also the only geologist on the moon. And so a lot of things that he learned, that he picked up, the orange soil, or things that no other astronaut would have noticed, because none of the astronauts were really geologists. They were, kind of trained as geologists on the way. All right, so we're now in what started out to be the Constellation program, which was going to return to the moon by 2020. It didn't happen yet, but the idea was that they would finish the IMS, mothball it, and go to the moon and Mars. And the idea was that they would sunset the space shuttle and use the Russians to get up to the space station and use the money that they would have put into shuttle development into creating these heavy launch vehicles to go to the moon and Mars. And so the idea was that it would fly the shuttle till 2010, get the crew exploration vehicle by 2014, and return by 2020. Well, you know, like a lot of things, it didn't make it, and part of it, the reason it didn't make it is there was a new president who didn't put the resources into it. But we still basically have kind of the same idea, although it's kind of been renamed. So now the mission is called Artemis. Artemis is the sister of Apollo, and so it's a lot of things are similar. It has a nose cone that's sort of bullet shaped, and which looks a little bit like the lunar return nose cone, and for the same reason. You're coming in at 11 kilometers per second, and so you need something that won't burn up on the way in. So the crew vehicle is called the Orion, and it will be landing on the moon. It's no longer looks like this. It looks more like a vertical rocket. But this was sort of an early idea, which looked a lot like the old LEM. But the other thing that's been added to the system now is a lunar orbiting piece, and that lunar orbiting piece then allows radio contact even from the far side of the moon, and to be used as a staging. So when they come back from the lunar surface, they go to this orbiting spacecraft, and that orbiting spacecraft then can be used to go on to Mars from lunar orbit. So, you know, here are some of the high priority places that were first considered, and some of the ones we went to before. Of course, all the early Apollo ones were done on the near side of the Earth because we wanted to be able to communicate with them. So whereas we have not had any human missions to the backside of the moon. Now we have had a couple of Chinese missions that landed on the backside of the moon, and it's a different beast there. But the really exciting place to land on the moon is the South Pole. And there's two big reasons why we want to go to the South Pole. One is that you have these craters near the South Pole that are so deep that they never see sunlight into the bottom of the craters. So any comet that's crashed into the moon, a lot of the water would have condensed down in this crater where it would not re-evaporate from sunlight. And so it became kind of a cold trap for ices. So we can use the ices both to melt it for humans to drink, but we could also use it to separate it for hydrogen and oxygen for fuel. But the cool thing about this crater that's near the South Pole is that the rim is always in perpetual sunlight. Now the sun sort of travels along the edge of the rim as the moon rotates, you know, every 28 days. On the equatorial part of the moon, you get 14 days of sunlight and 14 days of dark, okay? And that means your batteries and everything have to last forever. But if we put a colony on the South Pole, we could have a solar panel sticking up at the crater wall and just have the solar panels rotate once every 28 days and have power all all month long. So I've been working with the Houston Museum of Natural Science, and we create a number of planetarium shows. We were the first to do an earth science show in the planetarium. We were the first to do human body show in the planetarium. But one of our earliest shows were about, what a lunar colony would look like. And one of our very first shows, Earth's Wild Ride, was set on a lunar colony at the South Pole. And the grandfather who, came to the moon was telling his grandchildren who were born on the moon what the difference between Earth and the moon were. And it's a great show. It's still a good show. But we've created quite a number of shows that build on our idea of how you would have a lunar colony on the South Pole. There's also a brand new show called Forward to the Moon. I think you can watch it on YouTube. It's not ours, so we don't post it. All of our YouTube, all the shows that we've created, you can see on our YouTube channel, ePlanetarium, and you can see all the 40 shows that we've created. But Forward to the Moon really goes into a lot of the detail of the Artemis and how it works and when it's going to fly. So, Constellation was canceled, but they still tried to find the money to continue with the Orion and the Space Launch System, and now we're really getting ready for the very first true launch of Artemis 1, and so that will be tonight. The launch, it was going to be last month. It was going to be September, but these pesky hurricanes got in the way. At first, there was a fuel leak, and so they had to fix the fuel leak. And then there was a hurricane coming, so they, put it back in the assembly building to protect it. But we're finally going back to the moon with a major launch tonight. This is the sort of the path that Artemis 1 will do. It's going to leave the Earth and pick up some speed, and then it's going to go by the moon twice and circle the moon twice. So it will circle the moon twice and then come right back. So it stops going by the Earth to pick up speed twice. And you can pull all of these animations from our website. So my main outreach website is space.rice.edu, and you can find a lot of things there. So that's our passes by the moon on the way back. We wanted to make a swing by the moon that had minimum energy. So in case there is a failure of propulsion, the astronauts will get back. And that was what they did on Apollo 8. They did strictly a one swing by, so that it was a free return. So in case there was any issues, the astronauts would come back. So here's a kind of a animation of what that pass by Artemis might look like as it goes across the lunar surface. Okay, so we'll be there tonight, and we'll be launching tonight, and it'll take a few days to get there. We're traveling this time much faster than they did in Apollo, bigger engines. Okay, so who will be the first woman on the moon? But we don't know yet, but we do know women and people of color will be going to the moon, and that's very exciting. And we know that it will be an international program, and I think that's one of the the great things about the new space program is that it is an international program, and it does involve people of all types and diversity, shall we say. Okay, so why the moon, not Mars? Well, it's quicker to get there, and you get a faster communication time, seconds, not minutes, and you can get back in a hurry if there's a problem, and we have known resources. And then we also have that those craters can be natural shelter from solar storms and galactic cosmic rays. Galactic cosmic rays are a real problem for going to Mars because you're exposed to this low level but very high energy particles for the whole trip. We have the Earth's magnetic field, which protects us here on Earth. You don't get much of that protection when you're at the moon, but you have almost none at Mars. Okay, well, so I'm prejudiced because this is the instrument. When I move my mouse, it changes the thing. Anyway, I was a graduate student working with Apollo back in the 70s. And my advisor and his advisor had built the instruments that were sitting on the moon. So this is the particle detector that I used. And that's what I looked like when I was young and skinny. Those were some of the computers that we used that had, 2K of main memory, and each one was an individual transistor that would, in fact, occasionally get a bug in it. And so this was live data coming from the moon during the S4B impact, when after the astronauts landed, the last rocket module hit into the moon after they did, and it kicked up a big plume of dust, and we were looking at that. And so I got to go to mission control and got a mission control badge, which I was really excited. One of the coolest things was being in the ALSEP room and seeing the astronauts take off from the moon, in real time from Johnson Space Center, which was just crazy. The other cool thing is my first science paper was the August 72 solar storm, which would have killed the astronauts had they been in space at that time. So at the end of the Apollo mission, we turned off all the instruments on the moon, and I actually got to flip the switch to turn off the last instrument on the moon. So I'm really hoping that I can be there when the next generation of lunar surface instruments land on the moon. Okay, so since then I've worked on 8 NASA missions. This one was the IMAGE mission. It was launched from Vandenberg because it was in a polar orbit. This was me at, at 50 and a bunch of our team, one of my graduate students. This was another one of my graduate students. This is my postdoc. And this was Jim Birch, who was the mentor, one of my mentors, and he was the PI of the instrument. So this one had the longest dipoles ever launched in space, 500-meter tip-to-tip dipoles. And so all the angular momentum on this spacecraft was all of these wires. And we did not only passive listening of radio noise, but we did active sounding of the magnetosphere by sending out coded radio bursts and listening to the returns. We could determine the structure, the height structure of the upper ionosphere. The density is a function of height on the top side of the ionosphere. Bottom side is easy. We do that with radio from the ground, but doing the top side structure, we had to do from space. And then this was 15 years later, we launched the MMS mission. And this is one of my current graduate students. And so we're all a little older and a little but having a lot more fun. So missions are exciting, and it's fun to be on the forefront of science. What I do for fun is I have a portable planetarium company. We co-designed a portable planetarium with the Houston Museum of Natural Science, and we take it out on the road to inspire kids. And we've been using it lately to teach people about the upcoming solar eclipses going through Texas. So we got a Texas nexus that the eclipses are coming. And there's the map. So if you're, we will have an annular eclipse in October of 2023. And of course, you guys are old hands with eclipses because you all got the 2017 total. So the 2024 total is coming this way. And so both of them are coming through Texas, and basically everywhere in Texas is going to be at least 80% covered, and most of them at twice within the space of 6 months. The previous total eclipse that went through Texas was in 1878. And the next one to go through Texas is going to be in 2045, but it's just going to barely touch the panhandle. So we're doing a huge push now to educate people on how to observe safely in English and in Spanish, and really do our best to make sure that the students can observe it safely. There was a tremendous problem in 2017, and I don't know whether you had it where you were, but a lot of teachers were told they would be fired if they let their kids go outside during the eclipse, because they were afraid of liability. And that's just insane. We got to fix that. All right. So, if you've never been to a total eclipse, it's an amazing sight, and so we're trying to again educate the public as much as possible, and we have a planetarium show that we're working on now called Totality Over Texas. So we've been, I'll show you this one other picture, but it's not going to do that for me. Yeah, this, I don't know if you've seen these, but Miloslav Drugmiller takes multiple exposures of eclipses and fits them to linear functions, so you can really see some of the detail in the photographs, which normally you can see this with your naked eye with a pair of binoculars, but photographs generally don't do it justice at all. But because of his image processing technique, you can really see a lot of that structure, which your eye is able to see with a good pair of binoculars. All right, well, so Rice Space has had 3 women astronauts. There's Shannon when she was a graduate student, and that's another one of our alumni. This gal is the head of the astromaterials at Johnson Space Center, and this is me and a couple of my students. She's at NOAA at the High Altitude Observatory, and she's at Los Alamos. So we've been really fortunate to be able to graduate a lot of really exciting scientists from Rice. All right, so the challenges of working in space, the low G makes you lose calcium in your bones, the solar storms you have to, the galactic cosmic rays are steady, but you have to watch out for them. And certainly in the moon, you can mine for ice and possibly even for helium-3. Okay, so why do I teach ham radio? Well, it's a fun way to teach electronics, waves, and space weather, because space weather is what I do. You can talk to the ISS with schools. We just did that here in Texas a few weeks ago. The students really love to talk around the world, and I've been fortunate enough to have taught over 100 hams to get their licenses. And the nice thing about the ham radio community. I'm a space weather scientist, and the ham radio community is very much involved with space weather. It's kind of like the professional astronomers have an amateur astronomy community. So the hams are to us heliospheric physicists as the amateur astronomers are to the professional astronomers. So if you, there are a lot of really cool citizen science activities that people have used ham radio beacons to see the shadow bite out the ionosphere. And I should have put that map up. It was a really cool map that they did, where you could see the ionosphere just went away in the shadow of the moon, which was, and they're going to have an eclipse QSO party for these upcoming events. So you can either use it as a real QSO party where you're making contacts, or just put up beacons so that they can unfold the propagation. So be on the listen for us. I'm W5TAR. I picked it because it says star and I teach astronomy, but it's also teaches amateur radio. And then the Rice U Ham Club is W5YG, and I'm the club leader there. And so here's your QSO card for our Zoom QSO QSL. So thanks for having me, and I hope I'll be happy to answer any questions.
I'm curious if I can go. I'm curious about the class that is kind of like teaching teachers to teach class. I'd like to hear about that.
Okay. Yeah. Well, I run what's called the Master of Science Teaching Program, and I have a 4-course series. One is the solar system, one is stars, galaxies, and the universe, one is teaching astronomy lab, and the 4th one is the physics of ham radio. So I teach them everything they need to pass their technician license. We talk about antennas. We practice on the radio. It's not a ham cram by any means. We really go into it in detail. We have them put together simple circuits. They prove, the V equals IR by, plugging in and measuring things with multimeters. So the idea is to get the teachers with their ham radio licenses, so then they can encourage other students to do the same. And some of them have stayed with their license. In fact, one group got on the cover of the QSL magazine because they created a Yagi out of metal tape with his class. So some of them have really gone into it and really worked with it with their students. Others, just played with it for a while and then moved on. But it still is, to me, a great way of really saying, here's why the ionosphere works, and here's a tremendous example of it where we can talk around the world. And what's cool is I teach the students remotely as well as in person. So we have a Zoom group for my classes, and some of my students are not in town, and so we will have a radio communication with both with Zoom and then also over the radio at the same time.
So how often do you teach it? And
so I teach it every other year. Every year there's a 1-semester class. So their midterm is their ham license exam. And then they have homework where they do homework on antennas, and homework on electronics, and a homework on DC circuits, homework on AC circuits, homework, a space weather homework. And then as their final project, they have to do a presentation in class on a use of ham radio in emergencies topic or a space weather topic. And so they're going to be doing that in a couple of weeks. And like one of them's going to be talking about the Mars radio networks, because he's been in the military and uses the military radio networks. And we'll have one on Aries, and we'll have one on storm spotters, and we'll have one on the Carrington event, space weather event. So again, having them do the research and pick a topic, either in ham radio or in space weather, or preferably both, is part of the class. And I really like when you teach teachers, having them do a presentation where they're teaching really cements it. You know, I don't think you learn something nearly as well until you're required to teach it.
I think that's actually true. I think, Dean, you got your hand up. You're muted. You're muted.
Okay, I absolutely agree.
There we are. So I was curious. I used to work in West Virginia for a few years, and curious if you spent much time at Green Bank at all, at the radio observatory there.
I mean, I've been there, but I really haven't spent any time. My personal research is space plasma physics. So I do most of my research is with Earth orbiting satellites, measuring the electrons and protons trapped in the Earth's magnetic field, the electric currents and magnetic fields in the Earth's magnetosphere, and reconnection, which is the process where the magnetic field from the sun interacts with the magnetic field of the Earth and causes a release of energy, much as in a solar flare. So my personal research is all in space, although I do all the analysis here. You know, people, when were you in space? Well, I don't personally go into space, but I've sent my robots to space. So I personally don't work with the radio telescopes, but I know many people who did. And of course, Bill Gordon, who designed Arecibo, was a faculty member here. And I have been on that catwalk on the main horn at Arecibo, 300 feet above that dish.
Before it fell down.
Before it fell down. Ooh.
Yeah.
Yeah, that was really, really, really sad. But we were there for his 90th birthday, and so I was really blessed to be able to be up on that horn while it was still up. But I have many friends who have been involved in the radio dishes at the one that MIT Lincoln Lab has at Haystack. There was the Arecibo, the radio that was in Alaska, and then they moved it to Sonderstrom Air Force Base to study the aurora. So I did a rocket flight associated with measuring the ionosphere from the Sonderstrom radar facility. So those are the ones I've actually worked with data from, were those two with Sonderstrom and Green Bank, the one in MIT.
I see another hand up. So polite, everybody.
Hi, my name is Ron Kuhlman. I'm a professor of physics at Kettering University in Flint, Michigan. And I'm curious to know about the class that you mentioned. So I was thinking about trying to do something similar for our sort of introductory engineering, electricity and magnetism type course. So I'm curious to know, what do you use outside of sort of like the standard sort of amateur radio technician book for teaching stuff about space weather or these other things? I've looked around a little bit and had a hard time finding like a good introductory level book that's not too high level.
That's the problem. And of course, I taught sophomore non-majors for many years. And frankly, teaching teachers is about the same level as sophomore non-majors. Because you can't use calculus and you can't go too crazy into things. So I actually use the ARRL PowerPoints, but I add a lot of stuff to it myself, and I also stop, and demonstrate it, so every day we have at least a little bit of on-air time, so they hear it being said. We have one student who's a Rice student who's auditing the class. He's an extra, but he had never really used the radio. I mean, he'd passed the tests, but he didn't know the right protocols. And you'd be surprised. The teacher will say something and then pause and then try to say again. I go, no. Once you pause, you got to wait for them to answer. You can't keep talking once you've paused. And those kinds of things you don't get out of a ham cram. You've got to actually sit there with your hand on the mic to know, the way to talk, the way to have a conversation.
So do you take trips down to the club station with the class?
Oh yeah, well, the club station is the room I teach in, so we got the radio right there. We have it's not a fantastic one. It's a TRS 2000, so it's all modes, all things, and we have on the roof of our building both a vertical VHF UHF antenna, and then we have crossed inverted V 120 meter and 140 meter. The 40 meters the long length of the building, and the 20 meters the short length of the building, but it's on the 4th floor. So we get a good propagation because we're not running into local buildings, so we're high up. And then I always have as the person who's helping with the class is someone who's taken it before and has at least a general. So we go out and talk to each other on the radio, and we participate in nets, so they can they're each required to have 5 UHF VHF contacts and 5 HF contacts to pass class. And so we have some on-air time. But what we've done, which actually works amazingly well, some of my teachers are, in some random place without a radio of their own. We will be on Zoom, and I will tell them, look, when you want me to key down, do this with your finger, and I'll put the mic up to my speaker of my laptop, and they will talk through Zoom, then through my HF rig and make a contact. Well, it's no worse than Echo Link or IRLP. It's you're using one of your hops being the internet, but at least one of the hops is the radio. And of course, here in Houston, we have digital repeaters, a lot of digital repeaters here in Houston. So we've done digital work, and so it's a lot of fun. They've all gotten their contacts in.
Cool, very cool. Any other questions from anybody?
But as far as the space weather stuff, it's all my own stuff. I have a planetarium show called Magnetism, and I should share this with you.
So space weather is your thing.
Space weather is my research, yeah. So let me just show you. Let me just share one thing.
Because we all play with space weather all the time.
Exactly.
So can you can you explain why, if your solar flux is 165 and your A index is, let's say, 10 and your K index is 1 or 2, why the conditions still might not be all that great?
Oh, well,
because that happened during a contest last month and I was really bummed.
Okay. Well, okay, there's 2 things. You want to have enough EUV X-ray flux to give you a high density, okay?
Right.
And that gives you a good mirror. But you don't want to have a geomagnetic storm going because that makes the ionosphere turbulent. And
Right.
once it's turbulent, then it doesn't make a good mirror. It's kind of, can you see yourself in a waterfall?
It's a fun house mirror at that point.
Yeah, exactly. So this is my website, mms.rice.edu, and we have a space weather forecast where we look at the solar wind input, and this is our input function that going directly from the solar wind measured by ACE and now Discover. And then we have a neural network which predicts the KP index, the DST index, and the AE index based on that solar wind input. So right now it's really quiet. But the sunspot number is high. So this is actually a good time.
It's a good DXing time.
We're coming up to solar max, which is fantastic. So as long as it's in between storms, the propagation is great. I mean, let me tell you, my friends who are radio astronomers in California, because the propagation is so dang good on 10 meters, they are getting CB radio guys at 10 meters jamming their data.
Okay, I had an argument with somebody about this because the freebanders they're not supposed to be there. And they said, well, no one else is there. I say, I disagree. They're not supposed to be there.
It actually is channel 6 of the CB.
Yeah.
But they're way over modulating. They're way they should only be putting out a few tens of watts, so they only talk line of sight. But they're putting out kilowatts, and so it's. I mean, I was in Houston hearing the same thing that they were hearing in California. Mm-hmm. So, that's. I mean, they were very, very annoyed. So anyway, I have this magnetism movie, which you can watch for free here or on our YouTube channel. I have a space weather software that you can download and run on a Mac or PC, which has a lot of information and a lot of real-time stuff. So all of that is available free from my website, mms.rice.edu. And then from my other website, space.rice.edu. And then I have a whole section of eclipses and safe eclipse observing and eclipse animations that we've got in flat screen and fisheye. We've got cluster outreach, image outreach. So there's a ton of material on eclipses that you can get through from my space website. And then my last one is my Master of Science teaching. So here's my ham radio class. Is mst.rice.edu/phys501. And so here's the description, the overview, the learning goals, what are you supposed to be able to learn? And then here's the schedule and all the homeworks. So you can actually take a look at what I've been doing. And I do have all of this year's lectures on Zoom, if you really want to see them.
Do you really?
Yeah, no, so as I said, I've got them all on Zoom. But this just kind of gives you so I go through the ARRL modules, but then I do a lot of material my own myself.
Do you make you make them available? All the classes you teach, or
if at request, I mean, because there are teachers actually asking me questions, so I can't just post them for everybody. But if you if you want to look at them, I'm happy to let you look at them.
Okay.
We also have someone else with a question too that we need to get in there too. Before
Take it, Steve.
What was that?
Okay. Okay, well, I lost my thought on one of them, but okay, now I got my thought. No, one reason when we talk about solar flux, there can also be too much of a good thing, because if the solar flux gets too high, then we also get nervous about CMEs. And you might go into a little bit of that, Pat, for the benefit of those who don't know what a CME is. And while I have the floor, I want to thank you for your presentation and thank Kurt for inviting me as a participant. And you talked about people, the free banders say, oh, nobody's on 10 meters, et cetera, et cetera. That's why I'm an advocate of 1010 International. And those who have been reading that's why I put my the 1010 number on there, and I'm an get on 10 meters, make noise, and that's one of the purposes of 10 meters is so that people don't think it's a dead band. Too many people make the mistake of taking a quick spin across the band. The band is dead. The band is dead, and then they quit.
I like to explain it this way to my students. I said the level of ham license that you have really says how many people can you annoy. with a family radio, you can only annoy people in about 2 miles. With a technician, you can annoy people in around 100 miles. And with a general, you can annoy people around the world. Well, 1010 is one of the few slices that a technician can do voice on, right? But it's only in certain phases of the solar cycle do you really get very far on.
But including right now. I know
absolutely.
This morning when I got up and the sun was just coming up, 10 meters was actually open. First thing until the sun went down yesterday. I guess it was yesterday. It was sun up to sundown.
One time last Solar Max, there 6 meters was open to Europe.
Oh, not from here.
Which was crazy.
Not from
Oregon, yeah.
But not from Oregon.
But it was from
not true. We have a gentleman in Eugene we have a couple people in this area who actually made a few European contacts on 6 meters.
Recently? Wow.
No, I'm talking about last cycle.
Okay. Well, not from my house. Not with my antennas.
Okay, so let's talk a little bit about the difference between about just general solar activity and CMEs. Okay, so when the sun, and I have a whole different presentation on space weather, but when the sunspot number is higher, then the EUV flux is higher, and X-ray flux is orders of magnitude higher than it is at solar minimum. And that's quasi steady state. I mean, it's it does. The X-ray flux is stronger when you have a big sunspot groups, and so you'll see the X-ray flux vary with the solar rotation at solar max. But what causes geomagnetic storms are when these sunspot groups explode, and you see the white light as a solar flare, but the ones that are coming toward us are the ones that can create space weather on Earth. And the interesting thing about that is, if you're looking at some of these videos of the sun, and I'll show you a couple of them if you're. I don't want to take up all your time, but
we'll go. How about we'll go another 5 minutes?
Okay.
So,
but
I mean, because the sun's rotation as stuff flies out of it, that continues to rotate, or does that or that just basically fly out in the direction that it was left, because it had angular momentum, if you want to think of it that way.
That is really, really interesting. what happens is the particles continue to go radially, but because the sun is rotating, the magnetic field becomes a spiral. And it gets wound up, and it's called the Parker spiral after the Gene Parker, the same one from the Parker Solar Probe. So the particles do go out radially, but the magnetic field gets wound up from the sun's rotation. So anyway, when you have a solar flare, you've got a tangled up mess of magnetic fields on the sun's surface, sort of like you've taken a paper airplane and wound up the rubber bands, and so it's knotted, and then when you let it go, you can get all that tension energy back into kinetic energy. And that's sort of what a solar flare does. It releases the knots on your rubber bands so that that big blast of particles comes to the Earth. So the energetic particles come at nearly the speed of light. And so when you see the flare, you're in the particles. You don't get another 8 minutes. If you see it, you're in it. But the big blast of particles, the CME, takes anywhere from a day and a half to 2 days, something like that, to hit the Earth. And what was special about the Carrington event is that it came in only 18 hours. And it was so close, followed the solar flare, that it was Carrington who actually then put it together that the flare on the sun was responsible with the geomagnetic activity on Earth.
And Dean just said that Artemis was scrubbed again.
Did it say why?
Dean, did it say why?
Intermittent hydrogen leak.
But they
Pesky
had the
hydrogen.
last time.
A pesky hydrogen.
I tell you. You know, fun thing that speaking of hydrogen, one fun thing that the local hams here do are these high altitude balloons that have gone around the Earth 3 and 4 times. Those are just crazy. And the party balloons, they're literally pico balloons that you can buy in the grocery store, but they're full of hydrogen instead of helium. And the payloads are less than an ounce. And they have little teeny tiny solar panels. And they don't even have a battery. They have a capacitor.
And I don't know if, I don't think Josh is still here. He actually launches those as part of a class that he teaches.
Those are awesome.
Yeah.
Yeah, we go and see some of those launched. We don't do them in our class, but we go and see them launched. Great. Well, as I said, I don't want to keep